All right, good evening, everyone. Hopefully we are on the right microphone. Okay, it's not. Would be registering if that was. Yeah. Okay. Hopefully the sound is all right. This is showing the wrong one, but I think it. Yeah. Okay. Inside OBS, it's set to the right one, so that's why it's able to find it. If the microphone audio is a bit too low or something like that, let me know. I'll try to bump it up some. I think if I switch it there, I can affect the volume a bit more, but I will continue on for now. Hopefully it's about like normal. Let's pause that, pause this. Okay, this out of the way. Some chat's pulled up over here. How's it going, DJ Devin, as well as Beata Graf over on YouTube for Beata and Discord for DJ Devin. Sounds good. Thank you. Appreciate the heads up there. All right. So let's jump right in. Hello to everyone. My name is Tim. I go by FoamyGuy on GitHub and Discord. This is the Deep Dive program, which is a weekly live stream program where we are diving into the deep into the depths of CircuitPython. Sometimes we are going all the way down into the C code that is the CircuitPython core. Sometimes we're working on CircuitPython libraries or projects or infrastructure or debugging or documentation. It really just depends from week to week what is going on. If you are brand new, though, and you have no idea what I'm talking about, let's take a step back and just give you a high-level intro for those folks that might be new. CircuitPython is the main project that we are working with on this stream. The main website for it is right here, circuitpython.org. CircuitPython essentially is an implementation of Python that is designed to run on tiny computers called microcontrollers. There are a bunch of pictures of these devices over here on the downloads page at circuitpython.org. Essentially, all these devices have a relatively small computer built in, and that computer can run CircuitPython. What that means in practical sense is that when you plug these devices into your computer, they will show up like a thumb drive. On that thumb drive, there will be a Python code file. You can edit the Python code that is in that file and save it, and the computer that is built into these microcontrollers will read that file for you and execute the Python code that is inside of it. CircuitPython is an open source project. Anybody is allowed to use it. Anybody is allowed to, port it to their own hardware. So if you're a hardware manufacturer, you are allowed to port CircuitPython to your hardware. You don't have to pay anybody to do that. It's all free. It's all open source. It is primarily funded by this company, Adafruit. This is their website, adafruit.com. Adafruit is the company that is paying the folks who work on CircuitPython. So like I said, it's free to use. It is open source. It's available for anyone to do what they want within a very permissive license. Adafruit is the one who pays the team that works on it, though. There's a team of folks who work on the project full-time that are paid by Adafruit to do so. There are other people like me who are paid to work on the project part-time. And Adafruit is the one making that possible. So thank you, of course, to them. And then if you would like to help support the project, in a way that's not like getting involved in development, one of the ways that you can do that is just by heading over to adafruit.com, purchase yourself some hardware there. They manufacture electronic devices in New York, and they have lots of different microcontrollers like the devices that run CircuitPython. They also have all sorts of other things that you can connect to your microcontrollers to interface with. So, motors, servos, buttons, beepers, buzzers, lights, RGBs, pretty much any kind of little electronic doodad that you can imagine. They probably will make, if not make, sell over on adafruit.com. Many breakouts are designed and manufactured, like I said, at their factory in New York. Some devices are third-party, just sold through them. But the key thing with all of it is it's all kind of electronical hardware designed to kind of interact with at the microcontroller level. All right, so with that out of the way, let's look at, let's take a more specific look at what I want to work on tonight. So the first thing is going to be check in on the type annotation PRs over here on the EPD library. EPD library, that stands for e-paper display. This is the library for interfacing with e-ink devices. So if we head on back over to Adafruit here and search up something like e-ink, what we're going to find is there's a selection of different e-ink displays that you can connect to your microcontrollers and other devices. And if you want to use those with CircuitPython, this would be the library that you are using. If it is one of the more basic e-inks, like certainly something like this, monochrome, that's going to be using the EPD library. I would assume the same thing here for this grayscale one. The ones that I am less sure of are going to be like the multicolor. Like this one does red as well as black and white. There's a yellow one somewhere as well, I think. It looks like this one does red as well. I don't know if those are covered under this library or a different one, but yeah, definitely at least the monochrome, perhaps the grayscale as well. Oh, also before I do jump straight into that, I noticed over in the YouTube chat from a little while ago, sorry, I don't know exactly how long that got put in the chat ago. I know it was sometime before I actually started streaming, but I'm not sure exactly at what point. So over there to Sega Haley, apologies if I've mispronounced your name over there on the YouTube chat. If you're still around and you are interested, they have asked a question in the chat there that says, I purchased a 1 meter neon strips, wondering how I can control the lights. Yeah, so the thing that you're going to want to do if you are still there, my friend, for one thing, if you do head back to Adafruit and you find the product you purchased, so I'm assuming you mean something like this, like the 1 meter neon-like strip. If this is like, you know, there's a couple of different ones, so whichever one you got, find that product page, and if you scroll down towards the bottom, let's see here, towards the bottom of the description, there's going to be this link here, this guide. So this is RGB. So if it's an analog strip where you have like 4 wires to connect to it, you know, one for red, one for green, one for blue, one for ground, then that's going to be the learn guide that you want there. If it is a different one that has like neopixels inside of it, like this one here, neopixels don't connect with all those same wires. You don't need red, green, and blue. What you need is like a power, ground, and a data wire. So there's also a guide at the bottom of this. That's typically the best place to look for whatever product you did purchase from Adafruit. Look at the bottom of the description. Sometimes it will be maybe like down here at the bottom of the technical details. I have seen that where it's like below the video instead of above the video. I'm not sure if there's a rhyme or reason to that or if it just depends or whatever. But somewhere towards the end of your description, you should find a link to a learn guide. That learn guide is either going to be specific to your product or it's going to be a more general one like this NeoPixels one here that's going to tell you, generally speaking, how to interface with NeoPixels, which is what this particular strip is here. So long-winded answer, but head there, get to the Learn Guide link for your product, and that will show you how to hook it up. It will depend entirely on which one you got, though, so I can't just give you like a one-size-fits-all answer. So, hopefully that will get you pointed in the right direction. How's it going over there on YouTube to James Matthew Higgs? Thanks for joining us today, my friend. Buying Adafruit hardware from the website directly is the best way. Yeah, for sure. Best way to support them, yeah, for the work they do. Okay. So, yeah, EPD, this is where we're starting. This is a pull request that's in for the type annotations, and I'm thinking we're going to be having an update, I think, on this one. So we did one round of reviews on this. There's been some changes since then, and then we've got the new stuff here. So let's see, implemented in this branch, merged the other ones. Now we can view all the files here. Locally, PyLink completes without errors. On GitHub, it complains about the type image. which is part of PIL. So probably what this means is this person, when they're locally running Pylint, they probably have the PIL library installed in their Python environment, whereas in GitHub it will not be there automatically. We would have to put that in requirements. Although I think for image, I believe maybe we made a protocol in, I don't know if that's the right term, but I think we made like an alias or whatever. We made a pretend image inside of the typing library so that we don't actually have to have PIL itself, if I recall correctly. So let's double check that. That's going to be over in CircuitPython typing. It's here. Reminds me, actually, I have in the works for a different PR actually a need to submit a PR to the typing here to add the color alias. That's a different topic though. PIL, indeed. Yeah, we have this pixel access image is a protocol. Okay, it is a protocol. So what we want to use is this image here instead of the one from PIL. So let's take a look at the code. Yeah, okay, so they've put that in there. Oops, PIL. It can be imported like this. Yeah, but that's the tricky part, because the truth is I don't know the exact syntax for it. So it's going to be like from CircuitPython typing.pil import image, I think. But we're going to have to double check that because I don't actually know for sure. Whoop. It's like this. We're going to double check though. So I have a device connected, which I'm just going to use. Huh. Thought I had TO. Oh, you know what happened is I closed this PyCharm accidentally. That's right. I think we don't have typing, so I'm going to have to get that. I don't, that's probably not the right name, actually. We don't actually have a thing. We should have a sample in there. That'd be another thing to submit for a PR to this one. It's a weird place because like it doesn't actually run necessarily, doesn't actually do anything. But it would be nice to have at least an example showing the syntax for how you import it and how to use it. Here's what we're gonna do. Go to the bundle. I'm gonna go pretty much this, except for I'm gonna change this part to say that's going to look through all the libraries, all the files, and try to find the string that I gave it, which was here. We found some usages of it in RGB display and sharp memory display. I'm going to go look at that. Although this tells us right here, actually. Okay, that should mean that it is actually the circup as well, I think. Should actually work, I think. Didn't. Is it not in the bundle? It's not in the bundle. It's an awkward thing because you wouldn't, or like you ordinarily, you would not put it on your device. It doesn't necessarily do you any good on your device. Must not yet. Bundle. Have releases? It does have releases. It's MP wide. Just download it. An old school. I've not downloaded a library like this in so long. Wait, what? No, I don't want Did I take examples? And have the code in it. Okay, well that's having the actual code. Okay, leave that there. We'll fix that later. For now, though, what we do then is we just grab the actual code, I guess. IL additions, there you go. Probably the branch from when they were added. Back to main, update. That's the latest stuff there. Grab the library, finally we can put that on our device. We're gonna go to the lib file folder. And now we are going to make sure that that import works for us. That is really what we're trying to confirm here, is that this import is gonna work. Doesn't, but that's because it says it needs typing. It's like the Python typing, I think. I can't actually run it on a device in that case. So case we run CPython, but like this. Okay. It was a long road, but we made it in the end. Yeah. I'll go ahead and do start review. We'll make another quick pass through and see if there's anything else that catches the eye, although I have been through it, I think, a couple of times at this point. Although some of them was in the other files, that's right, so we'll see if we find anything. Ints for width, spy, bunch of digital in-outs for all of our pins, returning none. And is an int, data is an optional byte array, boolean, int or byte array, returns int, returns probably optional int, since it can be none. Oops. Bunch of nuns, index is int for x and y, 0 or 1. Inverted, turns none. Color for 5. Int returns none. Int xy width height color are all ints. Y width height color again. All ints returns none. String for string, int. String for font name. Size is an int, width, height, rotation. Int returns none, int. Y height color, all ints. Image is the image. Okay. And the rest should be more or less duplicates, truthfully. Like, most of the rest of this is going to be individual drivers for the individual displays, which are going to have like an init method and a couple of overridden things that are basically all the same as the one in the base class. Just the difference would be the init statement is different. The they call that sequence, init sequence. Spy, digital in outs, boolean. It's none. 1 returns any. Nice to narrow that further than any. We have command typed. Anything more specific? Okay, command is typed as returning an int. Therefore, I think instead of any, back down where we were here, I'm just gonna go back up and actually just mention here, same for all the other files as well. That way I don't have to I don't need to put a comment on each one. Like you have to follow through there. And all of these I'm assuming are basically actually the same at this point now. Everything that we're seeing Get item, set item. Oh, that's a different thing actually. MCP SRAM. Interesting. I don't know what that is. Self.write SRAM. That one might be tougher. That could be a SRAM. I don't know what that's reading from. I would guess it's probably like going to be bytes or int or something though instead of any, but spy view int. Value. What would value even be here? Erase the past number of bytes starting at the past address. So we get past a number of bytes. We get past an address. Address length. What is value? Writing that. Ooh, I don't know about that. Interesting. This should probably not be called erase, right? It should be like replace or something, because it's you give it actually putting data back. That's nothing to do with the type annotations though, right? That's just how this function was written initially. Union 0? Probably doesn't. Union. It's like maybe literal or something? It's actually interesting that it is. I wonder why it has to be 0 for that one. This one allows 0 or 1. I guess that other display probably just doesn't allow. Oh, okay, maybe it's a monocolor. Okay. Since name said it. Cool. Okay, caught up on that. Oh, right, yeah. And then this one will fix the, this should fix the pylint issue. Didn't mention it in here, but I'm pretty sure this will fix the pylint issue. Oh, it's the wrong one. I'm late for EPD. You get into how to use buttons on a monochrome e-ink bonnet. So I can't say as though I know answer to that off the top of my head. We could certainly take a quick look, though. Is it this thing? Number 5, these two over here, I'm guessing. Look at the Learn Guide. Nope, that's not the Learn Guide. See, here we go. This one, it's below the technical details, the Learn Guide. Sometimes in a slightly different place. Is probably pretty easy. It's just going on the header there. All display pins. There we go. Up button, down button, button usage. I think this is the Learn Guide you need. Peakmin 4 over on the YouTube there. Looks like those are connected to pins D5 and D6 on the Raspberry Pi. If you're using standard like Blinka and stuff like that on the Raspberry Pi with its regular header. If you're using a different thing that's not a Raspberry Pi, then those pins may be different for your device. I don't get what kind of file to put that into and how to activate it. Have you done anything else with the display yet? I mean, it would go into a Python file on your Raspberry Pi, and then you would run it with like Python 3 space and then your file name. Really, it would be the same way that you're running the file that is initializing and drawing stuff on the display as well. So if you have done that already, then it's essentially the same type of file that you need to create and run. If you have not done that already and you're like, just have a plain Raspberry Pi out of the box and have not done anything else to it yet, probably the first thing that you need to actually do is find this guide right here, CircuitPython on Raspberry Pi Linux. There will be basic setup in here that will get you up and running with Blinka, which is the CPython compatibility layer that runs on Raspberry Pi to allow you to use CircuitPython libraries like EPD. For what it's worth, you won't actually need EPD in order to use those two pins. So if you're just trying to get the buttons, you don't need the EPD library. You just need to hook up digital in-outs onto those pins. You have a BTC ticker on an RPi 0W. Okay, yeah. So the same way that you're running the file there, it should just create a new one with your buttons, or I mean, you could add code into that one you've got, I guess, right? And then handle your buttons inside of there. You'll just have like if, button.value is true, true or false. It depends if it connects to ground or not, whether it will go high or low, but okay. Next thing I want to look at is built-in SD cards. So I have acquired this device. This is an Inky Frame 5.7. This is a Pimeroni device. I accidentally hit it and it worked. This is a Pimeroni device with a Raspberry Pi Pico W on the back. It's just soldered with the castellated pads or whatever there. And then obviously, so a couple of things about it. It has a built-in SD card. It has a Pico W, which means it has Wi-Fi access. And then obviously on the front, it's got this nice 5.7-inch 7-color e-ink display. Right now we're looking at the display showing just black and white with the serial output. but it is actually a 7-color e-ink display, and it can output 7 different colors, although those 7 do include both black and white. So, 5 colors that are colorful plus black and white. Yeah, for sure. Let's see here. Some products. Let's see. Let me catch up. Learn guides are always below the technical details at the bottom of the project page. The first one we looked at, they were at the bottom of the description. Sometimes I think they're in the description too. Videos in between are usually from Lady Ada JP or Collins Lab. Actual learn guide of it exists is at the bottom. No, that first one, I forgot what it was. That first product we look at though, there was a learn guide link at the bottom of the description. And products don't have. Yeah, that's true. Flow meters. Yeah. Yeah, I think there's a couple of folks like Katney and Liz, I think, are always hard at work on the new learn guides and stuff. Okay. So this device has a built-in SD card. So I would like to be able to access files on the SD card, right? Makes sense. We don't want this anymore. Let's go back to device workspace, this one here. So oops. So if the SD card were mounted, we would be able to do something like this, and we would be able to see the files that are there. Because the SD card's not mounted, though, we can't do that. There's code in here that would mount it for us. So I could say like import mount SD in my case, because I have this file called mount SD and it has this code in it. Yeah, we'll let it do that. Why not? We can run that. So this will initialize the SD card. It will show us all the files on it. So now we can see the files that are there. If we like get back to here, so I did Control D and then Control C. It's back to not initialized. And that, I think, is because the CircuitPython virtual machine has restarted. When I did a Control C, Control D, I think I restarted the virtual machine. That means that all the stuff that had been initialized is now gone. So we could initialize it again, right? I could import it again, and then we'd be able to do it. What I would like to do, though, is I would like to see if we can set it up to where the SD card will get initialized inside the core automatically when the device first boots up, and then from then on, the user code can just use it without ever initializing it. That's pretty much how displays work in CircuitPython. Sorry, we've got fire trucks or something about to drive by. That's pretty much how the displays work in CircuitPython. Like when you mess with a display, it's you find it a built-in display, to be more specific. You'll find it on board. So you import board, you say board.display. And then at some point you could say, board.display.show to give it a group, or you could call refresh on it like I'm doing here. You can do whatever you want with it. But if you have a built-in display, this is how you access it, and you can start drawing stuff on it. Quick question, how will I change cards? Change cards. Oh, change SD cards. I'm not sure. I mean, just you can take it out and swap a new one in. I'm not sure if I understand what you mean though. Change SD cards. Oh, like if it initializes in the core. I see what you're saying, I think. Yeah, good question. I don't know. The short answer is, in my case, I'm not going to change SD cards. So, in my case, like the ultimate use case for this, the SD card will get put in and stay in. Very good question though. Yeah, we will need to probably handle that. So like it should attempt to initialize the SD card. If it fails, then it will go on without. Huh. Okay. I don't know. That seems unrelated. Yeah, potentially. Yeah, PyPortal has got SD cards built in as well. So if we can get this to work, then it could go on that device as well. Any device with a built-in SD card. Yeah, good question, Beata, on YouTube. I had not even really considered it. Definitely a good question. We definitely want to make it attempt and then fall back. And then we'll also have to work out what happens when you pop the SD card out after it has already been initialized, which I don't know the answer to what happens in that case. But we'll want to make sure nothing bad happens. Yeah, good point. To start with, I will plow forward assuming that the SD card both is connected when it boots up and assuming that the SD card will just stay connected and not ever get changed out. Yeah. It depends on the use case. Sometimes, like for some of the stuff I use SD cards for, I'm swapping them sometimes. But for other things, yeah, it is more like a hard drive. I just stuff it in there, and the only time I ever change it is if it craps out on me. But it depends. Like sometimes I change them out. There's a couple things I use with SD cards where I'll swap them out. Yeah. Pull it out to get the files off of it. Yeah, that's one thing for sure. Like in CircuitPython, there's no pass-through, so we can't look at the files on the SD card without taking it out, essentially. So that's one reason why you would be taking it out in CircuitPython land. But yeah, so I want to try. I don't know for sure if it's gonna work. I don't know what kind of drawbacks there will be as far as like what does happen when you unplug it. So there's lots of stuff to figure out, but I want to try to initialize it in there to where when it boots up, it will just have the SD card ready to go. So I did ask about this in Discord the other day, and Scott mentioned that he thought it would be possible it would go inside board and knit, I think. I'm actually going to pull up what Scott said, though, just so I can make sure I actually know what he said. Oh, it's not letting me because of this thing. Let's see. Net should be able. Code and board and knit should be able to. Okay. So I got a pointer from Scott to here. And so this is where it makes total sense because it is initializing the e-paper display as well. So pretty much what we would want to do is just initialize the SD card here as well. The tricky bit though is that what's the code to do that? It's going to look different. So in Python, the code looks like this. So for one thing, are these we can't use, and so we need to find the GPIO like this. So for SPI, we already have the SPI. We should be able to just reuse the same SPI as this. That's the good news. But the CS, SDCS, we can't just use board dot. So what we need to do is go look in pins and find it. There it is. Okay, so that is ampersand pin GPIO 22. So we need to create an SD card object by using this function inside SDCard.io, and we pass that to storage vs that. Then we call storage mount. So that calls common how display IO ePaper display construct and it resume is importing from there. I think I can control click through. Yeah, if you take it out while it's writing, or there's like weird file locks or something in place. Great gibberish and constructed files, corrupted files. So do we find this side of here? Maybe though, because of this. Okay. I think that's how we got that. Board here imported from display.io init. Inside of display.io init, it imported from display and ePaper display. And also some other things optionally down here, which ultimately allowed it to call inside of here common HAL display IO ePaper display construct. So if we go to yet? Shared binding. It was SDCard though, it was this one. Okay. But I think this is what we would be calling, right? Because that is calling straight to common HAL construct. That's what this is. I'm just going to use default. Working with SD cards pretty great. Have 128 gigs on a Feather. We'll play music from the SD card, no problem. Nice. Allow writes while you're removing or reinserting. Oh, okay. I wonder if it has a I wonder if there's like a pin you could check or something. I wonder if there's a way you could know it's plugged in. I guess you could try Lister like I did before, but I wonder if there's a different way. Yeah, I think we would not have self probably here, right? Hmm. Not very sure about this part. I don't think we're going to want to call it self, though. SDCard self? Okay. I think there's a very good chance that it doesn't work. So I'm going to add some print statements so that we can try to see output from it before and after it happens to see how far we get. Except I don't remember. That's right. Okay, it was right, but it's not shouty. I'm gonna do it between all of them. Okay, one thing too, do we want to catch this? Oh, that's where the self comes in. Weird, okay. I was like, do we want like SD equals, right? But no, we don't. It's actually, it would just be this. That's essentially the return in this case. If I'm understanding right, which I may or may not be. Yeah. So there, one thing would be like, do we want to put this on board somehow? I mean, we need the rest of these as well too, though. That's part of it, is like, would we want to also add the board? Like, there's board.display. Would we want board.sdcard or something? I don't know how to hook that up. I'm gonna go on here. Okay, so we have this stuff. We need storage.vsfat. Also, before I forget, we're gonna need to import. Right? How come this doesn't have inside H? The the function. This is in shared bindings. Okay, there we go. This is what we want to import. Shared module, SDCard IO, SDCard.h. Hopefully that'll work. We're also going to want the storage one. This is where it gets tricky. See, I think we're going to have to trace back and forth. We need to call storage vs fat. Then we're going to have to call mount afterwards as well. What? Seems like it's creating a object. And there's no vs fat. There are any Adafruit boards that have an SD card. PyPortal does. PyPortal, as well, it's PyPortal Titano. I'm not sure about the small one though. What is VFS fat? Oh. No, I'm in storage. Where does that come from? I'm in shared bindings for storage. There is no VFS fat. So if it's, I guess, coming from in here? VFS. Okay. How does the Titano do it? How does it, I could see it happening for third-party board, and they need board.sd. How does the Titano do it? I'm not sure what you mean. How does the Titano do? I mean, it doesn't do this, what we're doing here today. It doesn't do it at all. You just have to initialize it in your user code if you want to use the SD card, basically. Yeah. I do not understand where this function comes from. We have, it looks like we should have storage .vfs fat. But there's no mention of that in storage shared bindings. I don't understand how it gets pulled in. There's this. They're maybe related? I don't know. Okay, there's go. New. We have a woodpecker that has taken an interest in either some part of our house or a tree outside. I'm not sure which. Been back like 3 or 4 days in a row now. Yeah, I don't know. Maybe. You don't need the object is the thing. Like, even once you initialize it in CodePy, you can't do anything to that object. So there's no like if there's a function or if there's a property or if there's like literally anything that you can do with the object, then maybe. But as far as I know, like literally the only thing you do with this object here is pass it into this function here. And then literally the only thing you do with this object here is pass it into this function here. And then literally you can just never touch any of these two objects again, and you don't have to use them for anything. If that's the same case, then I don't see any reason to put it on board, because you can't, like, they don't do anything. More than that, though, I don't know how to do it, so I definitely will start without it, and maybe we'll go down the road to trying to get it there, but we'll have to see. Ask in CircuitPython dev. Anybody? Woodpecker. Yeah, Dinobite's a little aggressive sometimes. SDCard. Yeah. In the core. I'm not sure I understand. I guess basically you're saying what it yeah, I guess what you're saying more so like the core would keep a reference to it after you initialize it in user code, like it does with displays, which it does do with displays. Like if you initialize your display in user code, then it stays alive, stays initialized. Is that what you mean? I mean, the code there is basically the same code that I've got. So it is the code that you run in user code. But you're saying, I think with your comments, you're saying more so like, what if it worked this way? Yeah, I'm not sure. Okay. I don't know how to find what this is doing. text mod vs fat. So we're in the right place. Which function? Seeing. Make new, this one? I have no idea what we would pass for these. Because here we just give it SD, right? This says it's looking for type. No. Object. No, that's type. Yeah. Object type. Looking for type. In args as a size T. In KW as a size T. The object T args. I mean, I guess that's it, but I don't know. What are those arguments to? It's weird to me there's nothing in here either about that, like... I still am... I need, like, basic C learning, honestly. I don't really quite understand H versus C as far as... Usually I'm used to seeing all the functions that are defined in C to be listed in H, but that doesn't appear to be the case here. Oh, so I had my chat scrolled up. Let's see here. Init display and release displays would be another approach. Init on the SPI bus and the SC? Yes, I'm not sure. I'm trying to say is build the basic scaffolding into the core so that VFS survives VM reloads. I mean, that would be cool, but honestly, I don't think I have the ability to do that. Yeah. That would be really cool, but I don't think I am probably the one who can do that. Honestly, I'm feeling pretty stuck trying to even just do it this way with it hard-coded, honestly. Doing the long-term living and handling inside the VM and all, like, I don't even know where to look, right? I would not even know how to start beginning to think about giving that a try. Fortunately, that's just way over my head still at this point to be able to actually do the long live, handle it correctly in the VM startups and shutdowns and all that. Project. The only method I know that works 100% is putting SD to sleep. GPIO button to initiate. Mount? Like you can call unmount on you call unmount on one of these? I don't know. I've never actually unmounted it after I mounted it. How does this pull through from storage, though? I still am very confused by why in our Python code here we write storage.vfsfat. Like the glue between that and vfsfat here, do not understand at all. It's imported, so I guess that, I mean, the import has got to be then the thing that's pulling it through. There's unmount, okay. Oh, umount, excuse me. It's not unmount, it's umount. Vmount. Get mount. Erase file system. Enable USB drive. Enable USB drive. Storage module globals table. Mount. Umount. Remount. Get mount. Oh, okay. Okay, here we go. Now we got to the... Never scrolled down far enough. There we go. Okay. vfsfat. The ROM pointer. Okay, this is definitely one of the missing links. That's how it's linked up, but if we wanted to call it inside the core, how do we do that? I'll call this directly use storage umount. Yeah, I didn't even know about umount. Okay, we're so close, I feel. So, where did this come from? Does this appear anywhere else here? No. This is a string. It's definitely not this. It's definitely coming from this thing, which I guess we got from our import there. Wait, no, give me that back. Now I'm lost. I wish I could see the... I wish it would ... something else. I'm in the wrong file. Anything's open, honestly. Storage init H, close. Storage init C, shared module, close. SDCard, close. pfat vfss type external constant. Okay. bdev in. This one takes the right number of arguments, at least. Still there on the phone is so aggressive. Compared to the PC, it is like insane. Hello, that comment. Fix. Create a new object. Make the file system. Okay, this is returning none. Okay, so do we need all of this? Or would we need just this? MKFS. We're gonna pass the thing we make to storage.mount. So is that looking for this? I don't get to know because it's object T. MPVFS mount T? But that's creating it from an object. So maybe we don't want this full thing. Because that's basically MPVFS mount. It's different. This is FS user mount. MPVFS mount T. What is bdev also? I don't know what bdev is. Wouldn't it be bdev? Okay. There's somewhere else it calls this? No, just make new there. Okay. This is why that other thing is allowed to map up with this. Back here. This is mapping to this thing. So it actually doesn't, well, I mean, it passes bdev, but as the last argument. Args. Scroll down to 508. Formatting is not what I need. Wait, is this one? VDev is block device, okay. 74 T-mount. Copy not here. Crazy? Copy just missing? That's returning, so that does return a thing. Of course. Object T. Yeah, thank you for the heads up. I will, let's see. I need to include this from somewhere? Assuming yes. Alright, let's see if this builds or does anything at all. Probably want to use that auto detect function so it mounts auto detect function. I don't know how to use it. That does sound pretty cool. Inside VFS mount. Would this replace the last call? Storage.mount? Does that make it so we don't need to do that? Yeah, I know I'm like totally showing my ignorance about all of this, including C programming and SD cards and file systems and everything else, but I'm basically waiting around in the dark here, just kind of hacking slashing. I don't actually really know what I'm doing. Let's go. Name of the board. It's even built. It does build, and we're decent shape. Assume we're not like all the way there, but except for the fuse string, Q string found a couple hits. VFS, the VFS type calling the type calls, it makes a new slot, which is, as you must have already found, make new. Yes, okay. Okay. Oh, okay. That could be worse. That could be worse. Messed up a bunch of these. Yeah. Dev, okay, so we're mad because we don't have bdev yet. And SD card type we don't have. Okay. And that's unused also, which is fine. That one's fine. We don't care about that. So we don't have bdev and we don't have SD card type. I would have thought that would come from here. You're not serious. Doesn't let me find files this way, for real. I'm lost again. I don't even know which place I pulled this code from. But we need... Here's... We need this thing. Where does this come from? Oh, that's not what I want. Am I not copying? Find usages. One of them is mine. One of them is in SD card C. One of them is in NIT. Let's look at SD card C. But the thing is, we already imported from SD card H. Good bindings. Oh, maybe that's why. Okay. We need to import from shared bindings SD card H. Also. Maybe only, actually, I don't know. Probably also, right? Probably. Let's see if that gets rid of the first error. Not having SD card type. Yes, actually it did. It went super insanely fast. I don't know why or how it went so fast. That worked. So bdev, the next thing we need. Bdev from. That's not a good sign. Oh, okay, I'm in the wrong folder. I'm in the wrong folder. That's better. Okay. Only use outside of the stuff I'm doing. This bottom one is what I'm doing. The only use outside of that is in BFSC. Okay. BRB. I gotta run to the restroom. Be back in just a second. Okay. Oh dear. Obj. I mean, it has to be one of these things imported, right? But let's try a grep without the ampersand. Maybe that will give us the... It does, there's that auto detect again. $39. So inside of here, it gets passed in. So we need to find something that calls this. EFS object. 203. This is at mount. Input object has no mount method. Assume it's a block device and try to auto-detect the file system and create the corresponding VSF entity. So it just came from here, though. MP obj t. From I assume that's positional arguments 0, in which case it's the first one. Block device. Yeah, I don't know how to get that. Ew. Is it self? Is it this? I mean, I guess maybe that makes sense, right? Because we pass it SD, is what I said I thought SD self essentially is. I guess that makes sense. It's a little weird that this function takes 4 arguments, but the Python side here only takes the 1. A neat trick. All right, let's see. Does that build? Oh. Okay, hold on. No, that was all kinds of stuff that we go through. This wouldn't be highlighted. No. Compatible pointer type. Maybe it doesn't want ampersand. Void const. Void const? Might be stuck. Expected void const. The only place it's called. It's vfs.c174. Super. 174 is here. And it passes in bdev obj. So the only place in the core where it calls this is here. Passes bdev obj with an ampersand, which it got passed here, the obj t. And then we go up one because this just gets passed in. It has this stuff actually. Is this auto detect? Is that part of the API? I don't recall ever seeing auto detect before. I don't really get what it does. Or if it didn't find anything. This is called from two places. Well, no, it's declared in one place and it's called in the one place. It's declared at 139 and it is called in the same file from 203. And this is the one where it comes from the positional arguments. Positional argument 0. It's passed into auto detect. Inside auto detect, this. It's this stuff done to it. Maybe. It's not entirely clear to me if that's doing something to it or not. And then it gets passed to here. These are different. LF. Wait a minute. Okay. Mine doesn't have that LF. Where did I'm so confused now. I'm lost again. Where did I steal this from? I wish -n was the default. 174. Which is inside auto detect. Wait. Inside auto detect? Okay. Right. Yeah, this is FS1 or whatever. 1, 2. Okay. Now we go down to there. So yeah, it comes in as bdev object here. These two things happen. Unsure if those are important or not. And then it gets passed here. O3 is inside a mount from positional arguments. .181 is the declaration. 503, that one's new. Args. 503. Level helper function for ports to use if needed. Args, it says bdev and mount point. But that got passed into here. Both of them. Yeah, I don't know where to get our bdev. I think we're probably stuck. I don't think I can get this. Yeah, it's impossible because like everything is always just passing it in, but we can't ever get a look at like what was it? Like what would it look like if it weren't passed in? Well, we could keep trying to chase this, I guess, right? We could try to find this one because it's going to get past a bdev and a mount point. Maybe we'll find the bdev there, but I don't know. This feels like we're just hopping from stone to stone and just chasing it further up the chain, right? Like we have still yet to find where it came from. So these point to the same file at 498, which is where we're already at, actually. Only other one is in H. The only place that's even referenced is back over in H, and that's not going to be calling it. That's just going to be declaring it or whatever. Like I don't know what it's called, but it's going to be like saying the signature pretty much. Yeah. MP object T. Is there any reason to believe that we might catch a thing here? I don't know if you're allowed to do that. Any chance this could work? Feels so unlikely, but what do we have to lose? Computer blows up. Value ignored. Void value not ignored as it ought to be. Not supposed to be catching anything from that. We need to, like... Can we, like... Is there a way to go backwards from a more specific obj into a more generic? Like, is my problem that I need an MP obj? But what I have is a SDCard obj? But it seemed like it was looking for weed, though, right? What did this one say? It says expected void const star. Everywhere else that I have seen, it seems like that thing should be an MP obj. Looks like all of the places here where we grepped through, like here, MP obj bdev. So is my problem that my object is too specific? Do I need to somehow back out to MP obj? Does that make any sense? An extra M. And we need to try to find, where does that actually call again? Or where it's to let's go. Where is this from? I want to look inside of here, E3, to try to see if it looks like it's trying to convert it from an MP obj into the more specific SD card obj. Arguments look entirely different. FS user mount T, we saw that earlier. I do remember that. Im new obj. strangely, I don't see where this comes from here. Does have another one of these block dev inits also? I don't know. I don't think we're gonna get there. Back to being lost again because I don't know. I was trying to find. It looked like it was converting. Okay, so type is the first one, then we have a number, and then we have the fourth argument. 1, 2, 3, fourth argument. I have too many things open, and it keeps bouncing back to the end, and it's actually kind of frustrating as far as things that the IDE does go. So type int args. arg0 gets passed to block dev init. Yeah. I mean, I don't really know what I'm looking at, so what I think certainly could be wrong, but if I think it's feeling to me like we don't want this to be so specific. Does it just break entirely if we call this mp obj t instead? I guess yes, but yeah. mg, I did it wrong. Nope. Incompatible pointer type SDCard obj t. I do think this is weird how it's saying that it's expecting void const star. I don't really know what that means. So that particular error does not make it seem like it's interested in an mp obj t. Instead, I mean, honestly, it makes it seem like it's looking for null or something. But actually, that's probably just me not knowing how to read that. All right, what if we took these out for now? Let's see if this part compiles. Might get a build. Seems like we're gonna get a build. Did get a build. That's good news. That means at the very least we don't have like extreme compilation errors in the first half of what I've done. But I am pretty much at a roadblock, I think, on the next bit, because I do not understand how or what to pass in. Feels like we're so close, though, right? Like, it feels like it's got to be something pretty much, like, similar to what we've seen. So many things, like, everywhere is always just inside one of these 2 or 3 files. 96. Sure, I have already looked at several times. It's there again. It's the wrong file. FAT, not LFS. We don't. It's not passed. I mean, it has to be an NP-OBJ, right? Like, that has to be what it is. Did we try ampersand? I think I did, right? Didn't I try ampersand SD self? I think I did. And an SD card self, that feels like what it should be from the Python side, right? Because on the Python side, we create SD card, and then that's what we pass here. And then the analogy in C, as far as I can understand it, SD card self, I believe is SD, is this. I think that's the same object. So it would make total sense if that was what we passed to here. It just does not like it. Or I tried an ampersand. I mean, this is like insanely dumb, right? You can't just, can you cast? Is there casting? Right, there's no way, right? Really? Well, I mean, it can't be that easy, right? Could it be that easy? Can I use it somehow? How can I use it? So I don't want to call mount yet, because that's like a whole nother can of worms. Can I access anything off of this? Is there like, can I print it out or anything? Can I do anything with it? Because we just want, or is there a way I can suppress this compiler error? Unused? Because right now it's just like the only error is that this is unused. I don't know how. Is there like anything generic I can print from it? I think this will not succeed, probably. Will not succeed, even if I do remember to put a semicolon on it. Yeah, we're not allowed to add those things together. OBJ. How can I find out what this has on it? Is there like an ID or a name or a class or like a toString method or anything that I can call to get a string or a number, just so I will have something to print so that it won't be unused? This is going to be every line of code in the entire thing though, right? This is everywhere. Uh, we print from that. Can I print ampersand that? Like is that a pointer number? Is that an int for the memory address? What if I don't have new line? I really love high-level languages like Python, where like in Python, if I wanted to figure this out, I could just be like print dir BFS, and it would tell me all the things on it, and then I could find one that looks promising and use it. But I have no idea how to find like on this. I don't know how to figure out what it has. What? Worked. With that by itself, interesting. Okay. Okay, well, there you go. So apparently we can print that by itself. Not sure why. I don't know if we would want this or not. It builds both ways. It builds both ways, so I don't know if we would want that. Int. Blah. Where I follow, sorry. Syntax. Not sure I follow, sorry. It's like star or something like this, but I'm not sure. This treats it as used, so this actually gets us past that one bit there. I didn't think it would because it's not a string, but I guess it figured it out for us. I think I'm gonna call it a night here though. So thank you to everybody for watching. Thank you to all the folks who helped me out in the chat. Would not have even made it this far without help from especially Deshipu, Neradoc, and Anecdata. Appreciate all of you. Quick SD card file directory. Don't know if it'll help. For folks that are interested in this sort of content, I will be back tomorrow morning working on some more CircuitPython stuff. Okay, this is user code level. Yeah. SD card and stuff in here. By doing the unmount you were just talking about over there. Okay. Cool. So yeah, tomorrow morning I will be back at 10 a.m. Central Time. And I'll be working on some more CircuitPython stuff. I don't know exactly for sure what I'll be doing just yet, but probably a decent chance I'm gonna at least make a stab at trying to get the last of this, because now we have, if this code is right, it's definitely a question mark, right? We don't know for sure it is, but it compiles, so we're moving in the right direction. If that code is right, then we actually have one more function call we need to figure out how to convert into the core. And then after that, we would actually be able to start testing the SD card. So probably I'll take an attempt at that We did not get into WebSockets, which I put into the name of the stream, so perhaps I'll dig into that afterwards if we manage to get the SD card stuff working. Any which way, though, that will be tomorrow over on my own Twitch and YouTube. I'll drop links to that in the live broadcast chat, which is the same Discord we have pulled up here in the morning when I'm about to get started, so you can head there if you want the links. Otherwise, I will say have a good evening. Thanks to everyone who's watching. I hope you all have a good rest of your night and a good weekend and all that stuff. I will catch you all next time. Thanks.